Hi guys, today what we would do is time, speed and distance. Time, speed and distance is one of the most important topics. Believe me, you would get 2 to 3 questions in any of the exams from this topic. This is also one of the lengthiest topic in arithmetic as well as the basic numeracy, right? So let's begin this topic. What we would do is we would do the basic definition of speed, we would understand the concept of average speed, then we would go to relative speed, and then there are special application areas like trains, clocks and races. We would see few questions from all these 3 areas. But what we are going to do in today's session is we would define the speed and we would see some questions related to average speed. So without wasting any more time, let's go to speed, right? So speed is defined as total distance traveled upon total time taken, or S is equal to d by t. This we already know, right? Or we can write S is equal to S into t is equal to d, right? So we can also write this. This is the definition of speed. Units of speed obviously is derived from distance and time, which is equal to kilometer per hour or meter per second. So there is a unit of conversion as well. So 1 kilometer per hour is equal to 1000 meter divided by 3600 seconds, which is equal to 10 by 36 meter per second. So this is a conversion factor which is equal to 5 by 18. No need to remember this. Whenever you want to convert a kilometer into hour, kilometer per hour into meter per second, just multiply the kilometer, change kilometer into 1000 meters, change hour into 3600 seconds and get the resultant, right? That's it. So this is the basic definition of speed. Please bear in mind it's total distance divided by total time. This is how we define the speed. Also, the definition of average speed is total distance upon total time. So I intentionally did not define speed as distance upon time. I took it as total distance upon total time so that our definition of speed and average speed remains the same. Now let's see what do we mean by average speed, right? So train travels at 60 kilometers for 1 hour and 100 kilometers per hour for next 3 hours. What is the total distance traveled and what is the average speed, right? Total distance traveled is equal to distance traveled at 60 km per hour plus distance traveled at 100 km per hour. So distance traveled at 60 km per hour would be 60 multiplied by time, which is equal to 60 kilometers, right? Let's call it D1. D2 would be speed, which is 100 into time, which is 3, so it is equal to 300, right? Total distance is equal to d, which is equal to d1 plus d2, so 300 plus 60, it becomes 360. So this is the total distance traveled by the train in how many hours? In 4 hours. So average speed would be 360 divided by total of 4 hours, which is equal to 90 kilometer per hour. So kmph we also write as kilometer per hour, right? So bear in mind that average is not just the average of speed, so it's not 60 plus 100 divided by 2, it is the weighted average. If you see, actually average speed is nothing but weighted average, where weights are the time taken. So if we see average as weighted average, it would be equal to 60 into 1 plus 100 into 3. So what are the weights? 1 and 3 divided by sum of the weights, which is 4, right? So average speed is weighted average of the speeds, where weights are the time taken. So this again comes out to be 90 kmph, right? So this is the basic definition of average speed. right? So the question was very simple. You would not expect such questions in CSAT or in any other competitive exam. Questions in competitive exams are much more difficult. Let's go to a slightly complex question which says, so it's not complex, rather it would again clear our concept of average speed. A train travels at 90 km per hour. It takes a halt, so it's not half, takes a halt at 3 stations for 30 minutes each. Find the average speed of the train, right? So the question is incomplete. It has to be the time or the distance has to be there, right? Otherwise we are unable to find it, right? The distance traveled by train is, let's say, 450 kilometers, right? So this is the distance traveled by the train. Now let's say the train does not halt for any time. How much time would it take to cover this? It would take 450 by 90, which is equal to 5 hours. Now it's halting for 30 minutes in 3 stations, which is the total halt time is 1.5 hours. So instead of taking 5 hours, train is taking 5 plus 1.5, which is equal to 6.5 hours. So this is the total time taken by the train, right? So 5 hours to cover 450 and 1.5 hours as a halt time. So total time taken to complete the journey is 6.5 hours, right? Total distance is 450. Therefore the average speed would be this much, right? 450 divided by 65, which is equal to 4500 divided by 65, which is again reduced as 900 divided by 13. So whatever is the answer, it's nearby 70, right? Almost approximately 70 kilometers per hour, right? So you can see the average speed is lesser than the speed of the train, right? So this is what is instantaneous speed, right? So if we have to differentiate between what is given, this is instantaneous speed. At any given instance, the speed of the train is 90 km per hour, right? But on an average, if we see the speed of the train overall, it would be around 70 km per hour. Now let's go to next question. Here I would like to introduce a very important concept, so just be very careful about it. Walking at 5/6 of his usual speed, a man reaches his office 6 minutes late. How much time does it take to reach his office usually? Right? So here few things, right? We have formula of speed is equal to distance divided by time, or we can say speed multiplied by time is equal to distance, right? Now if distance is constant in two cases, right, then what we can say is speed and time is inversely proportional, which means if speed increases, there is an increase in speed, the time would decrease, right? And since they are in proportion, in direct proportion, they would increase or decrease by the same manner. For example, if speed becomes 1.2 s, right, the time would become t divided by 1.2, right? So that our distance remains d only, which is equal to st, right? So the time decreases, time becomes 1 t divided by 1 by 2, right? 1.2. So this is how the relationship between speed and time is there, right? Now in this, firstly, let's say the speed was s and time taken by the man was t, right? Now he is traveling at 5/7 of s, right? So 5s by 7 we can write. this multiplied by new t, let's call it t dash, right? So this t dash would be what? It would be 7 by 5 of the original time, right? Now what we are given is the difference between this and the original time. So 7 by 5 t minus t is given to be 6 minutes, which means 2 by 5 of t. So I'll write it fully. 7 by 5 of t minus the original time is given to be 6 minutes. No need to change it into seconds or hours, just work in minutes, right? So this means 2t by 7 was 6, right? And from here we can very easily find t, which is 6 into 7 by 2 or 3, 6 into 7 by 2 or 3 into 7, which is equal to 21 minutes. So he originally takes 21 minutes to reach his office. So the point I am trying to make here is speed and time are inversely proportional, right? So if in two cases the distance remains the same and speeds are s1 by s2, right, they should be equal to t2 by t1, right? So this is the inverse proportion between speeds and time. Now take another case in which time is constant, right? For example, a man is traveling with speed s1 for 2 hours and another man is traveling with speed s2 for again 2 hours, right? So both of them are traveling for 2 hours. So what distance would s1 travel? S1 would travel s1 into 2, which is equal to 2s1, and what would s2 travel? 2s2, right? So the distances d1 by d2 would be in direct proportion to s1 by s2, right? So this is also very logical. As we increase or decrease the speed in a given instance of time or a given period of time, the distances also increases and decreases simultaneously. For example, let's say I was traveling at 50 kilometers per hour. So in 1 hour, how much distance would I travel? I would travel 50, right? Now if I am traveling at 60 kilometers per hour, in 1 hour, how much distance I am traveling? At 60. So my distance also increases as the speed increases. So we say that distance and speed are in direct proportion. So these are the formulas which would come very handy in various cases. So I hope that you understand the relationship, the variance of speed with distance and the variance of distance with speed, and vice versa, right? Similarly, variance of time with speed and variance of speed with time. So if you understand these relationships, speed and distance questions are nothing but ratio and proportion questions to a large extent, right? So let's go to next question, which says a car travels at 60 kilometers per minute from A to B and from B to A in 40 kilometers per minute. Find the average speed. So average speed is what? Total distance traveled by total time taken, right? So the total distance is same in the distance between A and B is D, let's say, in case 1. So the time taken would be D plus 60 and from B to A it's again D. So time taken would be this much. So this is the total time taken. What is the total distance? It's 2D, obviously, right? So average speed would be 2D divided by this whole thing, which is equal to D by 40 plus D by 60. D would get cancelled and you would get an average speed, right? So this is how we do such questions. Now let's go to an interesting question. This is slightly complicated, but it can be solved easily nonetheless. Normally it takes 3 hours for a train to run from A to B, right? So normally at a given speed, train travels from A to B in 3 hours. One day, due to a minor trouble, the speed of the train has reduced by 12 kilometers per hour, thereby taking 3/4 of an hour more than usual. So we have to find the distance between A and B. Just notice that in both the cases the distance traveled is same, right? The only thing which changes is speed, and thereby there is change in time, right? So before the train developed fault, it took 3 hours. Now it is taking how much? 3 plus 3/4, which is equal to what? It would be 15 by 4 hours, right? If initial speed was s and final speed would be s minus 12, because it decreased, they would be equal to what? 15 by 4, this whole thing, this is t2, right, divided by t1, which is 3, right? So this becomes s divided by s minus 12 becomes equal to 5 by 4, right? If we solve this, it would become equal to 5 by 4, or we can say, if we solve it, s is equal to 60, right? So original speed of the train was 60 kilometers per hour, right? Original time was 3 hours, so original distance, or the distance between A and B, would be 60 into 3, which is equal to 180 kilometers. So this again, here again we are using the concept of proportionality, inverse proportionality between speed and time, right? There is another method of doing it. So that would be slightly tricky, but if you understand it, many of the questions would become slightly easy for you, right? Now see, a train was traveling for 3 hours at a certain speed, right? Which means if it's traveling 3s distance, right? Now it is traveling 12 kilometers per hour less, which is, for these 3 hours it is traveling this much less, right? Which is, it is traveling 36 kilometers less when it is traveling at a lower speed, right? And it has to cover these 36 kilometers in 3/4 of an hour, right? Because the distance remains the same. So for each of the 3 hours it has covered 12 kilometers per hour less, which means it has covered 36 kilometers less. So it's falling short by 36 kilometers to reach B. Now to make that good, it again take 3/4 of an hour at certain speed, at reduced speed, right? Let's say the reduced speed is V. So the reduced speed would be 36 multiplied by 4/3, right? Which is equal to 48 kilometer per hour. So this is the reduced speed. What would be the actual speed? Actual speed would be 48 plus 12, which is equal to 60 kilometers per hour, and the distance would be 60 into 3, 180. So if you see, the calculations have reduced quite a lot. What we have done is, I'll explain it again. Now it has traveled 3 hours and another 3/4 of an hour, right? So before any fault, what it was doing is, it was traveling 3s distance, right? If s was the earlier speed. Now it is traveling 12 into 36, this much distance less in those 3 hours, which means in those 3 hours it is traveling 36 kilometers less, and to make those 36 kilometers good, it is taking 3/4 hour more at the reduced speed, right? So 3/4 of V is equal to 36, which means V is equal to 48, right? So this was the reduced speed. Original speed would be 60 kilometers per hour, and distance would be 60 into 3, which is equal to 180 kilometers, right? I hope that you understand this trick as well. Now let's go to the last question of this session. Obviously we would be doing many more questions on speed, distance and time concept in coming few sessions. So it says a man traveling at 4 km per hour reaches office 10 minutes late, and if he travels at 6 km per hour he reaches office 30 minutes early, right? At what speed should he travel so that he reaches office on time, right? So here again what you have to notice is distance is the same, right? Distance is the same. So the proportion of the speed, which is equal to 4:6, should be equal to inverse proportion of the time. So it should be equal to T2 by T1, right? Now if walking on a certain speed he reaches office at time and at times and he takes T time, right? Walking at 6 he reaches 30 minutes early, right? Which means he is taking T minus 30. Walking at 4 he is reaching 10 minutes late, right? Which is he is reaching at T plus 10, right? So T minus 30 divided by T plus 10 should be equal to 2 by 3, right? Just rearrange the terms, you would get 3T minus 90 is equal to 2T plus 20, right? And T is equal to 1110, right? So T is equal to 1110 minutes. Now if he is traveling at 4 kilometers per hour he reaches 10 minutes late, which means he is taking 120 minutes or 2 hours. So what is the distance of his office? It's 8 kilometers, right? So to travel 8 kilometers, if he has to take 110 minutes, at what speed he should travel? He should travel at 8 divided by 110 divided by 120. Obviously we have to change it in hours so that we get the speed in kilometers per hour. So it becomes 8 into 120 divided by 110, which is equal to 96 by 11, right? So this is the speed at which he travels so that he reaches on time, which is equal to 8.7. So 8.72 kilometers per hour is the speed at which he should travel so that he reaches the office on time. So once again we are using the concept of proportionality or variance of speed and time. So this concept comes very handy and it would help you solve most of the questions, right? So this is all for this session. I hope that you understand the concept of variance very clearly. We would be doing a lot of practice in our assignments so that this concept is crystallized in your mind and you are able to solve any question on time, speed and distance. In the next session what we would do is we would cover the concept of relative velocity, relative speed rather, and also see the questions on the cases which we have listed above. So this is all for now. Thanks for watching this video and all the best. I hope that you enjoyed the video and I wish you best of luck for your preparation. Thank you.